Hello, everyone, and thank you for joining us for this Unlocking the Power of Water webinar. My name is Catherine Garcia, and I will be the moderator for the webinar. In 1959, AgSource was formed to serve Wisconsin dairy farmers. What began as a regional dairy records processing cooperative has now grown into the AgSource of today, serving industries that span the entire agricultural ecosystem, from cutting-edge soil, plant tissue, and water testing to agronomic consulting and full-service DHI testing. AgSource at its core is a source of truth. One test at a time, we help our clients make the best decisions, always grounded in data. I'm excited to introduce our presenters, Dr. Donald Sockett and Dr. Jim Friedrichs. Dr. Sockett grew up on a dairy farm in southern Ontario, Canada, and graduated from veterinary school at the University of Guelph in 1981. After graduation, he successfully completed internships and residency programs in large animal medicine and surgery at the University of Minnesota and Colorado State University, respectively. He obtained his PhD degree from the University of Wisconsin-Madison in 1991. Dr. Sockett has authored over 100 articles on infectious diseases of dairy cattle in scientific and lay journals. Currently, he works as a veterinary microbiologist and epidemiologist at the Wisconsin Veterinary Diagnostic Laboratory. Also joining us is Dr. Jim Friedrichs. He received his Bachelor of Science in Agronomy from the University of Kentucky, followed by a PhD from Virginia Tech. He's held the role as technician, supervisor, and lab manager and spent over a decade sharing his knowledge as a university professor in Kenya and Tanzania. Jim has been with AgSource since 2012, supplying agronomic and environmental information to laboratory clients and professional audiences across the Midwest. Currently, as a director of laboratory quality and research, he spearheads initiatives that continuously push the boundaries of quality and precision across our laboratories, ensuring every process exceeds the consistency and accuracy standards we demand for our clients. I'd now like to turn it over to Dr. Sockett to get us started.
So it's a pleasure to talk today, and a little bit of background. My purpose and our purpose in the talk today is to point out the importance of knowing what your water quality is on your premises or your dairy operation, and you should check your water quality, preferably a minimum of twice a year. Winter and summer works quite well. And one of the things that by working at a diagnostic lab, we see things that go wrong and things that happen. And one of the things that we have learned is we don't spend enough time talking about the water quality on the farm. What is the quality of the water the livestock are actually drinking? This is particularly important for dairy calves. So water is a forgotten nutrient, as I said. And in the big picture in the United States is the EPA regulates public drinking water through the National Primary Drinking Water Act and the National Secondary Water Drinking Act. And so national primary, you have to do it. Secondary means there's guidelines. In the United States, private wells are not regulated by EPA. The EPA only has approved 3 different chemicals for the treatment of public drinking water: chlorine dioxide, chloramines, and chlorine. These are the only 3 chemicals that are approved. And if you use a chemical to treat your water, we recommend that you use a product that's been regulated by a regulatory body, and you want to use what we call NSF Standard 60 approved products. That's really important for treatment of drinking water because that assures that the product is safe and you got purity. And if you got a safe, pure product, then you have predictable performance. In the United States, because EPA has not approved hydrogen peroxide, we do not know what the maximum allowable limit is. And if you don't know what the maximum allowable limit is, you can't evaluate efficacy. So also important to point out that the maximum allowable limit for chloride, and we'll talk about that later, is 1 part per million. And high chloride levels have been associated with health problems in young children and pregnant women. Just as I specialize a lot in dairy calves, but these are the common problems that we see. High sodium in the diet, the animals will eventually adapt. So after 1 or 2 weeks, the problem may go away. High sodium can cause scours. High sulfates can cause scours. And high iron can cause palatability issues, and it can cause what we call oxidative stress, which weakens the immune system, which increases the susceptibility to infectious diseases such as bovine respiratory disease and salmonellosis. High manganese will reduce palatability as well. And we've seen problems with this where the manganese levels have been so high in the water, the calves don't drink enough water, and that adversely affects rumen development. You need to know something about the hardness of your water, which is called total dissolved solids, because if your water is moderately harder or harder than that, you have to be aware of that and use acid rinses to properly clean and sanitize or disinfect your equipment in premises. This is some information was provided to me by a private water testing company in Wisconsin. And what the point of this is that in a little over 55% of the dairy operations at the laboratory test, which is largely from the Midwest, there's water quality issues. And this is just listed the most common ones that we see. There's very, very few studies in the academic literature on the effect of poor tasting water on how it affects milk production in cows. But I can tell you in herds I've been involved with, and the few studies there is, if you correct the palatability issue and the water starts tasting better to the cows, you typically see a minimum of 3 to 6% bump in production. Obviously, they're going to eat more feed for the increased production, but if you get the palatability issue fixed, you will have more milk production in your herd. And when you have palatability issues, the dry matter intake doesn't drive the water intake. The poor palatability of the water drives the dry matter intake. So the most common issues that we see is high iron, manganese, and sulfates in water, and that can be fixed with oxidation followed by filtration. Chemical treatment for oxidation is superior to iron curtains because the chemical treatment, besides removing the element like manganese or iron from the water, it also will control bacterial counts as well. And I can't stress this enough. Every operation that has a water quality issue problem, it's a site-specific solution. So your neighbor may have you may know somebody has one type of system, may work in your operation or may not. So you have to work with somebody who does a water analysis for you, in-depth water analysis, and comes up with you with the best solution to your water quality problem. And this is just to show the hardness criteria that's used. And a lot of operations that we have, it's higher than 10 grains of hardness. And that's really hard water, and you must use acid rinses for proper sanitation and disinfection. For example, the drinking water at my home in Madison is 23 grains. And so some people in the Madison area will have water is up to 25 to 28 grains. I had a herd in another state, I believe it was Michigan or Ohio, and their hardness was 90 grains. I've never seen water that hard before. So a little bit about water softeners that you need to be aware of is a properly functioning water softener removes the calcium and the magnesium from the water, which contributes the predominant contributor to the hardness of the water, and replaces it with sodium. So for every ion or ion of sodium of calcium, magnesium, it replaces with 2 ions of sodium. And what interests me is when I go to these farms, even though the water pellets are disappearing, I find about at the core of the operation is the water softener is not working. And I do that by checking with a sodium meter. So this is just an example, hard water analysis. This concentration is a parts per million, which is a weight concentration. So if you had a water analysis with the sodium at 50, it's going to stay there, and it's going to exchange. If it's 75 parts per million calcium, magnesium, it's going to exchange that with 2 sodium ions. So what is the sodium concentration in the softened water? Because calcium and magnesium have a different molecular weight than sodium, the correct answer is 280 parts per million. So the harder the water, the more the sodium you'll have in your water softened water. So if your water is not very hard, you won't have much sodium. But if your water is really hard, like I have in my home, you're going to have a lot of sodium in that water. There are alternatives to water softeners. Most common things is reverse osmosis water, or using a product like ScaleNet. They use a process called template assisted crystallization. It doesn't remove the mineral from the water. It just makes it so it doesn't form deposits and cause scaling on your pipes and stuff. Now, a little bit why water quality is important from the point of view of a calf is calves have a larger surface area relative to their body size than adult animals. Their kidneys are immature at birth, which means they can't concentrate water as much as older animals. Calves do not drink much water for the first 7 to 10 days of life. They must learn that when they have the sensation of thirst, that's eliminated by drinking water. So pre-weaned calves are very susceptible to dehydration, particularly when there's heat stress. And one thing that many people don't know is the type of heat stress, how it affects the type of dehydration you have is different for heat stress than it is for neonatal calf diarrhea. So for neonatal calf diarrhea, in relative terms, they lose more electrolytes than they do water. So that's why when you treat calves for calf scours, you can get away with a hypertonic solution because there's more electrolytes in there relative to water. The exact opposite is true with heat stress, and that's very important to know because you can't use full strength oral calf electrolytes for providing water to calves with heat stress. You'll make a bad situation much worse. So you want to use what we call hypotonic or hypotonic or isotonic solutions. Now, the normal fluid loss in calves is about 80 to 100 mils per kilogram per day. And so just to show you how much water they can lose, if they got a lot of calf scour people, you'll have a pretty typical thing as a fecal score of 3, which means that you have some solid but a lot of water there. They're going to lose at least 2 liters of water per head per day, in addition to their normal loss, which is 3.5 to 4.5 liters of water. So you can see why oral electrolyte therapy is so important for calves with calf scours. Now, remember that sodium and the high sodium and sulfates will cause diarrhea. That problem will be exacerbated by using electrolytes. So you have to know the cause of your diarrhea, because if you give oral electrolytes to a calf that has diarrhea from high sulfates in the diet, you can cause sodium toxicity in the calves. Now, in the United States, the current stats, about a quarter of the operations have neonatal calf diarrhea. Scours is endemic in all the operations. It's just a question of how bad it is. But in the average is about a quarter of the calves in our U.S. dairy operations get scours bad enough that they require electrolytes. So if you use the industry best practices, you can reduce the severity, the duration of the diarrhea. But about half the time, you don't affect the number of calves that are scouring. And the reason for that is you're not controlling the pathogen load in the calf environment. And so that's why proper cleaning followed by proper disinfection is so important. Because if you don't lower the pathogen load in the calf environment, the scours problem is not going to go away. So what are the properties of an ideal disinfectant? I'll go through it quickly here. You want to know that it's safe, it's non-toxic, it will kill the pathogen you're interested in, it'll kill it in a matter of seconds, is effective at very low concentrations, it's not affected by the temperature, it's not affected by the pH or organic material, and it can penetrate biofilms. And a biofilm is just a slime layer that the bacteria produced. And they live in these colonies here. If you look at the right of the picture here, in these colonies here, that's where 99% of the bacteria live, and that's called sessile bacteria. When the biofilm is formed, disinfectants can't penetrate the biofilm efficiently or not at all. So that's why proper cleaning, where you disrupt and remove the biofilm, is so important. In fact, proper cleaning where you get biofilm disruption and removal is more important than the disinfectant that you pick for use. And this is just to show you an operation. This is an operation in New York where showing where they had problems with respiratory disease because of improper drainage in the floor. So they had to put drainage in the floor, and the problem, the respiratory problem largely went away. And just think about it, if you got a 4 or 5 week old calf and it's consuming the equivalent of 2 gallons of milk or milk equivalent milk replacement per head per day, that calf is going to have about a gallon of liquid waste a day. So if you got 20 calves in the pen, you're going to have 20 gallons of liquid waste a day. That's why drainage is so important. Another thing that we've been talking about is the importance of a sanitary design. This is just a picture of a sanitary design at a dairy operation. And the reason that's important is because sanitary design makes your cleaning easier and much more effective, and you can do it more rapidly than if you don't have a sanitary design. And you can, to disrupt and remove the biofilm, you can do low pressure foam cleaning with a handheld foamer, or in what I prefer is larger piece of equipment like such as this, that's a 20-gallon tank. And the foam is created by compressed air. The quality of the foam is much better with compressed air than it is with a handheld foamer. And this next picture is just to show you, I was involved, I go to some zoological facilities, zoos in the United States, and I show them how to properly clean and disinfect their facilities. And this is one that we laid a high quality foam down on the floor. You can see it there. And then after we rinsed it away, we thermofogged it with chlorine dioxide to kill the pathogen of interest. The pathogen we were dealing with in this place was aspergillosis, which is the leading infectious cause of death in penguins in the United States. So you have to create a thick fog and maintain it for at least 15 minutes to get, and this is the ultimate way to disinfect an operation. One of the problems we have with our dairy facilities, to build and maintain a fog, you have to be able to shut the building up tight so the air doesn't leak out. And many of our facilities are not amenable that we can shut them up tight. So therefore, we can't do thermal fogging, which is the most effective way to get an infectious agent out of an environment. And you have to wear personal protective equipment as well. So I put this picture in here to show you. This is an Amiot calf feeder barn in Wisconsin. And I put this up to ask dairymen, what's wrong with this picture? What's wrong with the facilities design? And the answer is because there's nose-to-nose contact between animals, between pens, and because pathogens can readily spread between the gates, you only basically have, from an infectious disease point of view, one pen in that whole barn. And it's so unfortunate that you don't need much of a barrier. 2-3 feet is enough between pens, and you can markedly reduce transmission, particularly of bacteria and protozoan parasites between pens. But it's not done in many operations, which is really a failure of not the dairyman's fault. It's a failure of facility design. And I put this in here. One of the most common problems we deal with in calves is Mycoplasma bovis. This is a picture of an infected middle ear with a calf with Mycoplasma bovis. And the reason I put this in here is we have stumbled upon it, that if you treat the drinking water of the calves starting early with chlorine dioxide, and you will markedly reduce your incidence of respiratory disease in the calves caused by Mycoplasma bovis. And so you want good quality water, and you want to validate your concentration is correct, and you want to use a product that's certified by NSF, certified to show it's safe. And this is a system that I was involved putting in. This is a filtration system where you do a pre-filtration, you treat it with chlorine dioxide to oxidize the minerals and make them insoluble, and then you flush, then you trap it with a post-treatment filter. So we call those back flushable filters. Now, I see this all the time, and you need to be aware of this is a system of treating the drinking water with chlorine dioxide, where they take liquid sodium chloride and they mix it with an activator, which usually is an organic acid like phosphoric acid, like that, and then they immediately use it. Well, the problem you run into is that it takes time to activate your chlorine dioxide, that you don't have too much unreacted chloride in there. So for instance, at water at 55 degrees Fahrenheit, and when you activate it, it takes a minimum of 4 to 6 hours to get for the process to run to completion. At room temperature, it takes a minimum of 2 hours. So the problem if you mix it and immediately use it is you get very, very high levels of unreacted chloride in the water, which is much higher than the EPA maximum allowable limit. So I have this testing kit that I use, and I've tested a few operations. And if you remember, it shouldn't be higher than 1 part per million, but I've seen as high as 20, 30, 40 parts per million of unreacted chloride in the water, which, yeah, you just don't want that. It's not a good thing. And then that's the inside of the testing kit I have. So to finish up this, to show the importance of water quality, I've had operations that had high iron in the water, and when we couldn't solve respiratory disease, we couldn't solve salmonellosis until we fixed the iron problem in the drinking water. EPA maximum allowable limit is 0.3 parts per million. We start getting worried at 1 part per million and really concerned at 2 parts per million. But this is a different situation. This was in Arizona. I was called out to visit a dairy operation where they're raising Jersey calves, and they're treating approximately 80 to 90% of the calves for pneumonia before they reach 6, 7 weeks of age. And so I went out there and did a site visit, and everything they were doing was best practices. Their passive transfer immunity was outstanding. I used an ATP meter and check, which I validated and used in the United States. And now everybody's using it. The facility was clean, and but why are there all so many calves? And they had a consistent diet, and they're getting the equivalent of 2 gallons per head per day of milk replacer, or 2 pounds of dry matter per head per day. Why are they having this pneumonia problem? What's gone wrong here? This doesn't add up. So what I told them to do, and here's a few more. These were long barns. They had fans in there, and they provide the calves with shade and fans to move the air around for chilling. Why is it 80, 90% of these calves getting pneumonia? It's costing the producer about $100,000 a month for pneumonia, for antibiotic drugs, and that doesn't cover the cost of the reduced average daily gain in the calves. So what was going on here? And this is to show you a picture of the operation. And so I said, let's do a water, and I knew they had high salinity water, too high of salt in the water, too high salinity water. That's a common problem in states like Arizona and Texas. So I said, let's do a 24-hour water intake measurement. So we randomly selected calves between 4 and 6 weeks of age. And there was 24 calves that got the farm source of water, which was high salinity, and 24 calves got good quality water that was not high salinity. The day that experiment was done, it was done on a Friday. It was 106 degrees with 4% humidity. The calves that got the farm source water, the high salinity water, drank 2 quarts. And the calves that had the good quality water drank 8 quarts. So then we made a recommendation based on this observation. They're not drinking enough water. Let's put an RO water system in and make sure these calves get good quality drinking water. And once we did that, the pneumonia treatment rate dropped from 80 to 90% to less than 5%. And what we think was going on was these calves were getting subclinical dehydration because the water tasted so bad. And subclinical dehydration, we know, will weaken the immune system profoundly. So just to finish up, is water quality is important. You need to get it tested and measured. And if you have issues, work with an expert who can assist you and come up with a farm-specific solution for your water quality issues.
Thank you, Dr. Sockett. We'd now like to turn it over to Dr. Jim Friedrichs to tell us a little bit about AgSource's water testing options.
I'm Jim Friedrichs for AgSource Laboratories. Thank you, Dr. Sockett. Very interesting presentation. And it really does highlight the importance of maintaining or evaluating your water, making sure that you have good quality water. So I'm going to speak from the laboratory perspective, talking about collecting samples and submitting them to the lab and getting the analyses back and interpreting the results that you get back, how we can help you with that through AgSource Laboratories. Place to start with our services would be on our website, agsource.com, and there's a web page that's specifically focused on water testing. In that, you'll find an opportunity or place to select what tests you want, to order supplies, and to find some more background information about the services that AgSource provides for water testing. Submission form that we provide for you. Once you get online, you can either print this out or you can wait until it's sent to you with your sampling supplies. But the submission form asks for specific client information that we can set up an account for you, an email address where we will be able to send results back to you by email, and then the more specific information pertaining to the sample. Where is what's the identification that you want to have on the sample? Where did it come from? The date and time it was collected is very important for us in that there are specific holding times for some of these tests, and so we need to know when it was collected and make sure that we can perform the analysis before the holding time expires on the sample. There's two parts to our basic livestock suitability test. This first part is kind of a basic test where we analyze pH, conductivity, total dissolved solids, which is measured off that conductivity, and then the soluble concentration of nitrate, sulfate, chloride, sodium, and iron. And that's the fundamental part. And then we have an additional part where you can add to that calcium, magnesium, hardness, alkalinity, and bicarbonate alkalinity, the sodium absorption ratio, important for some of those places like Dr. Sockett was talking about with high salinity, and then manganese, which is a palatability issue again. So these are the two basic tests that we do. There's an option where we can perform a bacterial analysis and measure the total coliform bacteria and the fecal or E. coli bacteria load in the sample as well. So sample supply, water supplies in your barns with this full suite of analysis will give you the full picture of the quality of water that your animals are taking. Excuse me. The reports, when they come back to you, will have the results, the method that the result is determined by. So most of these are EPA approved methods, or they're all approved methods, but most of them are EPA methods. The result of the analysis, and then a qualification of that analysis. So we will tell you whether it's low or satisfactory. Being satisfactory is kind of the upper limit of what's acceptable, and then cautionary and critical. If it gets up into those areas, that's where attention needs to be paid to that analysis. For example, the iron at 0.273 ppm is cautionary, and if we're over 0.3 ppm, that's when it's critical and needs to be addressed with some of the remediation that Dr. Sockett talked about. So for all the tests that we provide, you get this kind of a report and an evaluation of your results of each of those analytes. If you want some more information, you can go onto our website and look up the interpretation guidelines under our technical bulletins, where we have the list of analytes again, and what are those ideal limits. You want to be less than 50 ppm calcium, but the upper limit for that okay or satisfactory level would be 200. If you get above that, then you're into the area where you have hardness problems and need to do something to dissolve that. And so we also give you some possible problems that come from that, as well as the sources of the problem. As a laboratory, we're not in the business of making recommendations of how to treat your water, but we are giving you some more background information of what may be the cause and what might be the problems that you look out for in your livestock from drinking that kind of water. If you did submit a bacteria sample, this is the kind of report you'll get back for that. It's a little bit different. We don't do the qualification of the value. It's more of a report that's similar to the drinking water quality test that we perform for human consumption. And we list the results, the limit of quantitation that we can actually report, the value or the dilution factor of the value if there is a dilution factor involved. And then, because again, the dates are important here. If it was received, the day we received the sample is the day it's prepared, and then the analysis report date is the next date. So those dates that you sampled and submit and the time are important, especially for this test, because we need to have the results. We need to have the sample in the laboratory within 24 hours and starting the analysis within 36 so that you get the results accurately from the analysis. To get started with this, you can order your supplies on the website under that water page, or there's another homepage that has ordering supplies. Just open that up. There's a place where you can fill out your name, address, shipping information. If you have an account already set up, it will be billed to that account. Well, I shouldn't say that because these supplies are free, but we do need to, if we have the account, we already have your address. So material can be shipped directly to you. And the supplies that we send for a livestock water test, well, for the two basic tests, or for even for the most basic tests, we'll send you 2 bottles. The bigger one is for the pH, the conductivity, total dissolved solids, and then the soluble nitrate, sodium, and chloride. The smaller bottle in the middle is a bottle that has an acid in it for preserving the sample. And we preserve the sample so that we can get the sodium, the iron, the calcium, magnesium, and the hardness, which is a calculated number from that, as well as manganese. So depending on the test you get, you will get both these bottles, but we we'll take some readings from each one. If it's the livestock suitability plus, all the tests come from those 2 bottles as well. The third bottle, which is the little one on the left, is a sterile bottle that we send out only if you ask for the bacterial analysis. And it is, as I said, sterile and sealed. Inside that bottle, there's a powder that's a preservative that will maintain the bacteria in a stabilized state, so that when we get them in the lab, they haven't continued to grow, but they reflect the quality of the sample that you collected when you submitted, when you took that sample before submission. So you can see there's a tag involved in each one of those. Those tags identify the sample as well as the tests that will be performed on those samples. So just want to make sure that you fill out both of them well so that we can cross-identify the sample with the information sheet and get the right sample back to you with the right information. So when you do get the sample, fill the bottle up to the appropriate level, which should be right at the neck of the bottle. Fill out the information form. Be sure not to rinse the bottles out. There's preservatives in the bottles that need to be maintained. And then send the samples to the laboratory. They need to get to the laboratory within 24 hours. So that means don't sample it on Friday because there's nobody in the lab on the weekend to receive a sample. And you probably won't be sampling on Sunday and shipping overnight. But make sure that you can ship it if you're within proximity to where the lab is, which is in Ellsworth, Iowa. Next day air from anywhere in the country or UPS overnight will generally get to the laboratory within 24 hours. So submit it so that it gets there Tuesday, Wednesday, or Thursday. If we get it on Friday, that's fine. As long as it gets there early, we can set it up for analysis, and somebody will read the results later that weekend. I think that's all we have. Thank you for listening to the presentation. Now I think Kate will come back and we'll take time to answer questions if you have any. Thank you.
Yes, we did actually have a few questions come in. The first one being, I have 45 grain hardness. What issue might I expect in cows and calves? They do use water softener for cleaning, but not for all consumed water. The all consumed water is untreated. Dr. Sockett, have any thoughts on that one?
Yes, when the water gets hard like that, you have to have an acid rinse after you. So you start out, you do your alkaline washing step with use a chlorinated alkaline detergent for equipment or alkaline foam for buildings and such. And then you rinse it, but you have to do an acid rinse, which will solubilize those minerals and remove it from the equipment or the environment in the building. Because if you don't, that creates habitat that makes it much easier for the bacteria to attach to, colonize, we call it, and start producing the biofilm problem.
Is there an issue with water hardness for consumption of animals?
No.
Next question we had come in. I don't believe I have any issues with my water, but how often should I be testing my water?
Well, ideally, that's a very good question. So ideally, I like you always want to have a water sample drawn in the summertime because as the aquifers get drawn down with summer use, the composition and the quality of the water can change quite a bit. So as a minimum, I like to have a water sample done sometime in the summertime, and then another one done in late winter, early spring.
Perfect.
Let me just add something to that as well. Now I should have said this in the presentation, but the sample, I think it's important to collect samples in one close to where you're treating. If you have a treatment process, collect a sample there, which is close to the treatment process, and then another sample at the farthest end, away from the farthest end of the plumbing, away from that treatment, so that you know that the treatment is being effective throughout the whole process. There are things that happen in residence time in the plumbing, and so it's important to collect a good sample at both ends of the barn.
That actually, thanks, Jim. That answered one of our other questions that we came in, which was where should I be taking my water samples? Anything to add to that, Dr. Sockett?
Well, I tell people to do is you want to get your one sample as close to the well as possible, and you want to do bacterial counts and an inorganic or mineral analysis. And then what you want to do is sample one or two sites the farthest distance away from the source of the water, so it goes through the water distribution system that the livestock are drinking the water.
Perfect. Jim, this question came in. If I order bottles from AgSource, how long are the preservatives good before I have to get those samples back to the lab?
Preservatives are stable, so if you want to keep supplies on your shelf, you can do that. I wouldn't hold them for 6 months because the laboratory likes to get the bottles back. When we send them out, we like to get them back. But if you need to hold it for a couple, 3 weeks, there's no problem with that. Once you open the bottle, especially the bacterial sample bottle, once you open it, you need to fill it right away and reseal it. The other one with acid in it, yeah, it doesn't matter how long it's stored, but just be sure you don't rinse those out before you use them.
Okay. And then we noticed on the results sheet that there was kind of a gauge on acceptable or critical levels, but not on the bacteria. So what are acceptable levels for bacteria in livestock water?
That's a good question. I'm not sure that's well defined. The E. coli or the fecal coliform bacteria level, you want none. So anything greater than 1 is a concern. For total coliform, we've seen, and Dr. Sockett and I discussed this earlier, we've seen advisable limits of maybe 10 is an appropriate action level, maybe 100 is appropriate action level. Depends on the age of the livestock, I think. And the kind of livestock. We talked primarily about dairy, but for swine and for poultry, those limits are probably lower as well. I'm sure, Donald, you may have something to add to that.
No, as we learn more and more about E. coli and coliforms and stuff, what we've seen over time, people are doing a better job. And so the standards keep getting lower because people are doing a better job. And so I tell people zero tolerance for E. coli because that means fecal contamination. Now I know if there's a community water that you can't, that's a problem, but you don't want zero E. coli. And then in the total coliform count, I don't like to see it much higher than 100 bacteria per milliliter of water.
Okay, great. That was all the questions we had come in. I really appreciate Dr. Sockett and Dr. Friedrich's time today. Thank you everyone for your time today, and we hope you have a wonderful day.